Hi guys, assalamu alaikum. If you are a Muslim, if you're not Muslim, hi. So let's continue. So you are the next team, and I am the architect of this project. And I have continued this project from the previous team, and we did quite a lot of work here. And I will explain everything one by one. So I will start from the big picture. We open and read the read readme markdown file, and also the four folders. I'm gonna open it with Visual Studio and also start the project. And also I will explain the data flow, and I will also explain the backend modules and AI pipeline, and also the AI agent. Now the AI agent service and also its tool loop, and also its tool calling, and also the confirm UI. Also, I will explain a bit of atomic design, which is a front-end architectural design pattern we commonly use to make our project pretty much easy for the upcoming people to use, and also to have organized workflow to make your work easier. Okay, and also the shared types. Yeah, we have types, enums, and um, DTOs, also the schema model. So I will explain it a bit later. And also rules, cloud.md, and so what's left. Okay, so let's get started. I will just explain everything here using the project. The first thing you have to, if you use Cloud Code, which I do recommend, instead of writing code on your own, but you must understand, you must guide the AI, not AI guiding you. If you let the AI guide you, what you are going to receive is garbage. As you have to check the output of the code the AI generated. You must see the code differences and the newly generated code, and you have to test it a lot of times. Okay, so I have done a lot of work here. Pretty much, maybe 75% of the project job has been done by me. And I depreciated the dashboard the web uh, previous team has done, because I thought that it is not it's not important and it should be depreciated. It is my own opinion. If you want to continue the dashboard, you can take it and continue the dashboard, the web. But we did mobile here on my phone. You can basically write the code, and the build the features, test the features. You can basically test on your phone. Here I'm using Expago React Native Framework. uh, okay, so let me explain everything. So pay attention to this my tank. This is the dashboard and homepage of the React Native app. So this part, it will calculate water parameters and other things, and then it will show you the critical alerts, and also there's push notification. This is clear right now. uh, and you can do quick actions. You can feed your fish here. Once you click it, the motor spins, and then gives food to fish. It drops food. And also there's controllers, and you can ask AI agent here. You can move to controllers here. You can feed your fish here, and also you can manually turn on air pump and turn off the LED light. Also, everything is managed by the AI agent. So the AI agent is triggered when we have a critical situation. Let's say that uh, let's say that the pH level is bad, or let's say that the oxygen level has dropped a lot. So in this case, the agent will be triggered by the notification, and agent will turn on the air pump, and also it can turn on the LED as well on its own. And also for the convenience of the user, we add this one. So it's easy. Just you can test This is just for testing. You can test it on your own. When you click this and that, it turns on the pump and LED. Okay, let's move on. And you can even make scheduling here. Here what we are using in, so I will move on the services, separated service. We have separated services for main, backend, and then bridge server, and also AI predictor and other pre-trained vision models. I will explain them in detail later. But here you can basically do scheduling as well, like whenever you wish. So there is a cron job in backend, so it's easy. So when the time comes, so this one will be triggered automatically. You can set it, and also AI can do it as well. AI agent can manage it. Also the smart lightning, you can turn it on and off. And also later on you may bring smarter LED, so you can change the colors here, but the one we have is only one color. Also you can change the brightness and when to turn on and off. And also you can set even a cleaning reminder to yourself. We don't have any sensors or things in the aquarium to clean itself, but you have to do it manually, and you can have a reminder for yourself. Also emergency notifier here. You know when it is dangerous for fish, temperature or the pH level or the oxygen. Also you can use the push notification here. And let's move on to the Veronica AI aquarium assistant. This is AI agent, not just AI. You have you can have conversation with it. It can extract the data from real sensors. The water level is good, the pH is good, and also it can check fish behavior as well. And also it counts the fish and does a lot of work. You can do it by having communication here, but you have to give permission to the agent whether it should ask you for confirmation, or it can do everything automatically. So you can set the Veronica watches sensors every 5 minutes and takes action. If everything is good, it doesn't do anything. If something is wrong, it does action. It does take action. You can change it here for later on if you guys uh, want to make a production grade product. You may have you may continue this part as well, the free plan and tank name, and also you have to have a lot of work on the device and aquarium itself. Maybe you can have pairing device number, and save, and everything works on its own. Here's the settings here. You can even change the aquarium name as your email, and push notification on sound, Veronica voice. You can turn it on and off. And also tank save ranges, you set it here in advanced. So you have to pay attention here each time when you are developing or when you are extending this project, adding new features and working on it. Make sure that all the services are working correctly and all of them are online. You can refresh here too. Backend, you must run the backend and the real-time socket for live telemetry, also Veronica AI and AI predictor. We have YOLO model and Convi LS TM VAE. So you can refresh it here. So after you make sure that everything is running here, then you can proceed. You can um, start working in it. Also, the version here, it is definitely version 1. And also, Sejong University Capstone 2026, and so privacy and terms. You may extend it only if you are going to do production grade stuff. Okay, so what's left here? So I explained the controllers here. There's the AI. Oh, here. Right now, I don't have the device. the professors has have already taken it, and my friend had to work on it to train the AI models. So what it does, it finds the this is the tricky way. I highly recommend you guys to buy a better camera, ESP32, this type of camera, uh, which can be connected to the Arduino. Find better high quality camera and take the video and picture from that camera and direct it to the bridge server. But here, what we have done is really trouble making and a lot of headache. To be honest, what we are doing is we have a lot of headache here. So the camera we have is not accurate, so we have to use the iPhone camera, and you need you need your iPhone. You need to have MacBook, and everything is working on MacBook. The project is must be running on MacBook, and connect your phone to MacBook. You reach your phone camera through your MacBook QuickTime Player and route that camera to your to the bridge server, so that the AI agent and the backend can take images to calculate the numbers of fish and their behaviors and everything. So this is the headache part. In the beginning of this project, search for better camera and connect it to Arduino. So this is the best and optimal way. Okay, and usually here you can so the it detects cameras on your phone camera as a refresh after everything is connected. The camera is connected, your phone connected, and then this stream will be available. You can see it in real time. Also, everything works well. So I think I have explained already the project. Also, the history here, you can check it for 30 days and 7 days and 24, and the latest reading and today. And this is just the history. Also, we have database as well. Okay, now let's move to, okay, what should I do now? Okay, let's go to VS Code here. Okay, let's move on. Mm, close everything. So I really recommend you to start from, so whenever you are making a project, or whenever you are working on a project, software, and if you are a software engineer, so what you should start is just reading the package JSON. So what is package JSON? Package JSON is the let's say that the metadata of the project itself, how you started, what packages are installed, what are the dependency packages, and also the scripts, how you start the project, how you run the project, how you compile the project, how you build the project. Everything stays here. So as you can see here, now this one is the root package JSON. What we have, scripts. You can see the script, so you can basically call here and open up terminal, clear, so you can say pnpm dev. So everything is, right now I'm starting everything, so everything is working, so I don't have to do it. So the workspaces, we have how many workspaces? Okay, what we are using, uh, the build dependencies we need, better SQLite 3, this is the database, and some bcrypt, and also the parcel watcher, nestjs core we need it, so es build sharp, these packages are needed, and also overrides here, react dom, react native. Okay, Now let's move to now I will go to the front end where you will be working most of the time. And uh, okay, and then after you read the package JSON and read the README file, you can see the folder structure and then important data you need. And so the data flow and everything is here. The general data. As you can see that the architecture in here. Also morality. Also this part I have done it, and also this part I have done it. And then AI agent I have done it. So she did a little bit of AI training and she quit. And he was the leader and did only 5% of the work. And in order to start all the projects and stop it, you can easily run this shell script. You basically, if you are using Linux or MacBook, that this works. If you are using Windows, I'm sorry that this thing doesn't work. This is the thing that it starts all the applications at the same time. You don't have to come and enter, write down pnpm start dev and move to the expo npx start. Da, 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 da. You don't have to open up new terminal tabs and then type everything one by one, one by one. Also, the good thing that Cloud Code has. So, if you open the Cloud Code, basically you can start. This is they have preview. You can open it and you can start like whatever you need here. And this is the serial breach, which is the mock data. This is the after if you have connected the real uh, aquarium, you start this server. This is the this is the serial bridge as the backend as expo our mobile app, and Veronica LLM as AI predictor, the vision models, and also the mock Arduino. Right now I'm starting mock Arduino. If you start all of them, then everything works as expected, and you check here whether all of them are running or not. Okay, now what do we go? Where do we go? Okay, folder touch. Let me explain the folders here. Here are the apps. The assistant. They did the Python with Python desktop stuff, but you may continue it or not. But these are the depreciated code. This is the dashboard website. It's just only a website, just a little bit of work. But if you want, you may extend it and continue the work. But the main thing is here. Main thing is the mobile app here. You work here if you are developing the mobile mobile and also the AI agent. You will be working here. This is the part you work mobile, and this folder this consists of the documents, the blah 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 document, and also the project status, water quality, and LLM setup, and also if you really want to see the communication layer detailed diagram, I do recommend you to study a bit of entity relationship modeling. This is a very crucial thing when you are extending the project. If you don't know this, and if you do not know how to make the diagram and how to follow it, I am afraid that you may not extend this project. If you want to see this diagram, you go to web and open it with MMD. Mermaid viewer. I will show you. Now you come here and you paste it, and you can see here. If you want to have understanding of how the architecture is designed and how things work and everything, just come here and run it and use it. It gets the fish house and so pretty much most of the routine here. I don't have bigger screen, so I am so sorry. This is the dashboard. This is the serial bridge. I recommend you to study and see this diagram before starting any work. There's also the list detailed Control Z list detailed document diagram. Uh, yeah, this one. This is a less detailed one. If you are making presentation, just you can directly show this instead of showing the big one. Okay. As operations, also the phrase here, you can open and read these ones. Also serial protocol, also the superbase setup, the database setup, also the team ownership. You may change it if you after you take uh, what you are going to do. You may change this one and continue. And also, I have done a technical debt report, historical snapshot of the previous team, what they have done and how. So what kind of work I needed to do. Everything is detailed here. What the previous team did and what I have done and what I have uh, what I should have done. Okay, so there's a docs folder here as a firmware. This is the thing that the hardware, the person who is doing the hardware should check this folder and read this readme file, and then they will have which pin to what pin what pin needs to be connected to which pin and which analog and which sensor should be which pin. Everything is here. And also there are each of us are making separate documentation for what we have done. I also have done documentation. You may download it and read it to understand. Also, this is the code that you change when you are updating or adding new sensor. So you have to load this code to Arduino using Arduino integrated development environment. You have to load this code to Arduino itself so it can respond to your requests. The main sensors and also secondary activators here. Okay. These are the logs. If something goes wrong, it will be here. Errors will be here. So whatever happens, errors will be here, and you may check it, read it, and you may fix the bugs. And here we keep uh, the the trained model and their weights, and also the behavior classifier, and also frame video classifier, behavior video classifier. Here in the beginning we wanted to use YOLO, but later on we added two new vision model. The behavior model works uh, with video, not picture, so you may need to download them as presentations. This thing is for the yeah, you may have the presentation and PPT. Um, yeah, you have to make presentation and present what you are doing each week. So you may delete this one our presentation and add a new presentation of your own. You may also check out these presentations for more information. And okay, they have resources folder and a scripts folder here. This thing, you need this thing to start the vision models here, and how they work, and how they detect fish, or yeah, just read them. This is the part of the guy who handles um, AI. No, the behavior and fish count, which is related with the picture or video that's being sent through the server bridge, from server bridge main to the LLM, the vision model. So, and also we come to the sweet spot services. Why I have divided to three services. So usually when you are working with a team, and there will be a lot of conflicts when you are pushing your code to GitHub, and when you are updating the version of the code. So, and also to be able to work better, and for organized work. Okay, so AI predictor. What AI predictor does? Come here, read the package JSON, read the requirements here, and check out what is here. And also check out the env, the camera. Where is the camera? It takes the picture of the fish and sends to your main LLM. Go ahead and read this code. Leaves here. Yeah, go ahead and read. This part is also the one who's working with the camera. Yeah, basically camera, and then the behavior, and then the other stuff, and the backend. This is also heavy work here. Um, it says the backend, the main one. You come here, you read the readme file. You will see what to do. What is we are using a progressive Node.js framework for building efficient, scalable server-side applications. This is a framework of Node.js. I will also explain the technologies we are using. Wait a bit. So I will explain a little bit. So the Nest.js is Node.js framework to build server-side applications. Basically, this is the server, and the concept is very easy and good. So it strictly follows to the old traditional architectural design pattern for server-side applications. MVC, model with controller, but we remove the view model modules, like model controller. It has modules, controllers, or resolvers if you are using GraphQL, controllers if you are using REST API. We are using REST API here. So modules, modules, controllers, and um, service models. Okay, so come here and wait, no, don't move. You open here. You open source folder. All the source code will be here. Also, there's a guide for migration as well from the other team. And uh, in Nest.js, everything is divided, and it is module based. So every module is different. Every module is separate, and it does what it does, and the modules are connected to each other. So as you can see here, the first thing you open is you check the main TS. You come here